Children, let us now start with another type of reactions. The name is endothermic reaction or process and exothermic reaction or process. Now, in this type of reaction, say endothermic. The word endo we have studied. Endo means inside. And the word thermic is associated with thermal energy, that is heat. So when heat is absorbed in any chemical reaction, then it is called as endothermic reaction. Heat is absorbed inside, that is by the reactants, so as to get converted into products. Then it is called as endothermic reaction or a process. Similarly, exo means outside. Again, thermic or thermal word is associated with heat. So exothermic, when heat is given out, it is released or liberated, then it is called as exothermic reaction. So here we are going to study a couple of reactions and processes about endothermic and exothermic reactions. Let us first deal with a endothermic process. The example that we have taken is KNO3. KNO3 is potassium nitrate. Here I have shown you how to make a formula for potassium nitrate. And you have to take solid form of it and then dissolve it in water. When you dissolve it in water, what happens is that these reactants take up the heat from outside. They take up the heat from the surroundings and they get converted into products. Here the product is KNO3 aqueous. That is an aqueous solution of potassium nitrate is obtained. Now, since the reactants are taking up the heat from the surroundings, it is an example of endothermic process. Here this reaction is not going to be a balanced reaction because here we are studying it as a process. It's an endothermic process that we are studying. So don't worry about the balancing of this reaction. It's just an example of endothermic process. So suppose if we start this reaction or this particular demonstration by taking tap water. If I have taken tap water, the temperature is somewhere between 20 to 25 degree Celsius. Now when you add KNO3, since heat is absorbed, you will find that the temperature of the solution decreases. Means if it is anywhere between 20 to 25, it will show you temperature less than that. If for example, the temperature of water is 22 degrees Celsius, it will be below 22 degrees Celsius. So it's an endothermic process. Heat is absorbed. Here we are not supplying any heat. We are not bringing about heat. It is absorbing the heat from the surroundings. And the temperature of the solution decreases. Coming to the next one, that is NaOH. This is solid form and this is water. Again, tap water we have taken. You take the initial temperature of water, say it is 23 degrees Celsius, and then you add NaOH to it, and it is easily soluble, highly soluble in water. And what you are going to get is aqueous solution of sodium hydroxide along with heat. Now heat is written on the product side, so heat is going to be released in this case. So heat is going to be released, so the temperature of the solution, you will find that it has increased. It will be more than 23 degrees Celsius. When you actually perform, you can see and feel the beaker in which we have carried out this reaction, and you will find that the beaker has become very hot, and that is on account of the heat that is released. So it's an exothermic process. The process in which heat is given out or it is liberated is called as exothermic, and heat is evolved or it is liberated. Here temperature of the solution increases. It will go on increasing. So these are two examples of endothermic and exothermic processes. Now one example we are going to study in the next slide. Now let us see one example of endothermic and exothermic reactions. The first one, calcium carbonate, and heat we have written on the reactant side, and the product is calcium oxide and carbon dioxide gas. If you remember, we had done this as an example of decomposition reaction. The only difference was that we had written heat on the arrow. So here what have we done? We are supplying this heat in order to convert the reactant into products. So heat is getting absorbed during this process by calcium carbonate to give you the desired products. So calcium carbonate, when it is heated, heat is absorbed to break the bonds and finally get converted into products. So since heat is absorbed during this process, it is an example of endothermic reaction. So here the only difference between what we have studied in the previous slide, that is of potassium nitrate, it was absorbing the heat from surroundings, whereas here calcium carbonate is absorbing the heat that we are supplying. So endothermic process can be it can include either absorbing heat from the surroundings or the heat that we are going to provide them externally. So this is one example. We know the products calcium oxide and carbon dioxide gas. So during endothermic reactions, heat is either absorbed from the surroundings or has to be supplied continuously from outside. So here we are continuously supplying the heat from outside to convert calcium carbonate into the products. Coming to the second example, that is calcium oxide and water, and it is going to give us calcium hydroxide and heat. So this is also we call this as lime, quick lime. Calcium oxide is called as lime or quick lime, and to this we are adding water, and this is slaked lime, that is calcium hydroxide or lime water also we call it as, and heat is given out. So this is also one example that we had studied under combination reaction. So combination reaction, we had said 2 or more reactants give you single product. So this one we have studied, but here what is happening, heat is given out during the chemical reaction, that is the products whatever you are going to have, the temperature of the solution is going to increase. So here it's an example of exothermic reaction. So during exothermic reactions, heat is given away or it is liberated or it is evolved when reactants are transformed into products. So this is one reaction each as examples of endothermic and exothermic reaction. I hope you have understood this topic, and next we will move on to the a different type of chemical reaction. Children, next topic that we are studying is the factors that affect the rate of chemical reaction. Now, what do we mean by rate? Rate refers to time. There are some reactions which take very long time to complete, whereas there are some reactions which are completed within very small period of time. If you take example of from the everyday life, the formation of curd from milk, it's a long process. It's a chemical reaction. It's a chemical change. But this change to take place, that is conversion of milk to curd, is a very long process. So it's an example of a slow reaction. If you want to convert the milk into curd within a short period of time, which will definitely take a certain minimum time, but if you want to lessen it, what do? You keep the milk in a warm place. If you are subjecting it to a place where there is a lot of warmth, the conversion takes place faster. Similarly, on the other hand, if we take an example, that is you take a lighter and you light your cooking gas. You ignite your cooking gas. So what happens is within hardly a fraction of a second, it starts burning. So it's a very fast reaction that is taking place. So there are some reactions which are fast. There are some reactions which are slow. So generally, we want reactions to get completed faster so that we can get the products faster. And we want that the reaction should get completed quickly. So what are those factors which will help us to complete a reaction fast? So there are some factors that we are going to study which help to determine the rate of a chemical reaction. How can we increase the speed of these reactions? So let us study the first factor. The first factor is nature of reactant. Nature of reactant is the first factor that governs the rate of chemical reaction. Now in this we have taken an example to make you understand and that is aluminium metal is made to react with dilute hydrochloric acid. Means the hydrochloric acid is not pure, it has been prepared in water, and that is an aqueous or a dilute solution of hydrochloric acid has been prepared. And to that we have added aluminium metal. What are the products? Aluminium chloride. I have not written down the name of the product, but you must write it down in your notebooks. That is aluminium chloride is the first product, and the second is hydrogen gas. So two products are formed here. Now how this aluminium chloride has been formed, I have explained it here on one side using the balancing and then crossing it. Second example that we have taken is zinc. Zinc metal is also added to hydrochloric acid, that is aqueous dilute hydrochloric acid, and the product is zinc chloride. Write down the name, zinc chloride, and aqueous solution, and hydrogen gas is released. Both these, that is aluminium chloride and zinc chloride, both are salts, but they are water soluble salts, so they dissolve in water, and so we get water soluble salts, aluminium chloride here and zinc chloride in this case. Both the cases we are getting hydrogen gas. What is to be noticed here? The thing that is to be noticed is that in which reaction is the evolution of hydrogen gas faster, whether it is with aluminium or whether it is with zinc, because in both these metals are made to react with hydrochloric acid only. So in which of the case is the evolution of hydrogen gas faster? So if we observe, we find that the evolution of hydrogen gas is faster with aluminium, whereas in zinc, the evolution of hydrogen gas is slightly slower. So what is the factor that determines the rate of chemical reaction here? So here two things we have to study, that is the nature of the reactant. Aluminium's affinity for hydrochloric acid is greater as compared to that of zinc for hydrochloric acid. Since the nature of aluminium is such that it reacts with hydrochloric acid vigorously and its affinity is greater, we find that the hydrogen gas evolves faster as compared to zinc. The second thing that we need to see here is that aluminium is more reactive than zinc. Again, I will ask you to go back to metallurgy lesson, and there you have a reactivity series of metals where the metals have been arranged in the descending order of reactivity, that is decreasing order. And if you see the positions of aluminium and zinc, you will find that aluminium occupies a position on top of zinc, that is aluminium is above zinc. Zinc comes a little lower, and so we find that aluminium is more reactive than zinc. Since it is more reactive than zinc, the reaction is completed faster and the evolution of hydrogen gas is also faster. So this is one factor that determines the rate of chemical reaction. So if you bring in contact those reactants which are having greater affinity for one another, the rate of reaction can be increased. So this is the first factor. Let us now see the next factor.